we're going to jump right in rather than wait around for people to come here. Today is Sunday, but we had a thing on Saturday. So we're doing week 19. Just a couple disclaimers before we get into it. So the first thing is, and I have to say this every time, I need to start saying it again because I keep getting reminded of it. The reason I'm able to do these beginner boosts for free is because they're messy, they're ad hoc, they take no preparation other than a general idea of what we're going to cover. And there's no editing involved. I just want to put that out there because a lot of people say, why don't you edit videos? Why don't you put this Udemy thing out? Blah, 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 blah. We had somebody recently actually ask, I don't want to get into it, but we had somebody recently ask if they could have permission to fully edit all of my Beginner Boost videos and post them as their own for identity or recognition or something. And just a reminder that this content is 100% mine. You cannot reproduce it in any way outside of the license, which is YouTube license, which means you got to get my permission other than the regular fair use stuff. That includes the written content. So you can come to the content as is and use it. Okay. And that's what it's here for. That's why I do it. The reason it's messy, the reason I do it at all is because I have a full-time job, I have a family, I like to go outside, I have lots of other things that I do. And so this very, 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 very messy live content, you get what you pay for, right? And this is the amount of effort I'm willing to put into something that's free. If and when I were to ever really clean this up and put it into a course or Udemy or something like that, I would reserve the right to do that myself, or I would sell that right to somebody else, okay? So it's going to be messy. And don't copy it, okay? I have to put that out there because a lot of people are really enjoying the content, so much so that they want to do a service to others by boosting their own live streams. I have no problem with you working through the content on your own. If you're working through the content on your own, you want to live stream that and watch the videos and then pause and then do it together like as if you were reading through a book. That's fine. That's more or less fair use. It's not, but that's fine. What's not okay is for you to selectively edit the videos the way you want to, publish them on your own site as your own content, and then just say, oh, I just wanted to edit out all of the talking and ranting and everything and make it a nice service for somebody else, and then have people going to somebody else's place for my content. That's not okay. Okay, I have to put that out there. That's why I'm going to continue to do it for free. How you doing, says Ever Turn? So what are we doing this week? This week we are going to be doing... we're going to take the procedures and functions we learned about last week, which I'm not going to talk about. You should know the difference. If you don't, go back and watch it. And we're going to start doing it. So, the function and procedures are a group of steps or tasks. And when we started getting into, flow control or boolean logic and things like that, it's like, okay, now how do I repeat these steps? How do I... we already talked about organizing the steps into little kind of mini programs inside of a program, procedures, or things that have one result functions. And we're not going to completely abandon the procedure function thing. There's still some things we need to talk to about that, but we're going to talk about that in terms of the steps, how we take that in, and that'll become apparent. So for example, we still need to talk about parameter expansion. That's something fancy you can do with those arguments that come into your function or your program. Or your procedure. And then we also have to deal with if this, then do that. If this is true, then do this, right? We also want to show you how to do regular expression matching in Shell and Bash. And that we're going to spend a lot of time on that. That might actually need to be its own hour. Because, we've already done regular expressions. We're not going to recover regular expressions. What we're going to do is show you how to use regular expressions in Shell and in Bash, and they are different. Even though you can use set in both, you should probably only use set in Shell. We're going to talk about why and talk about how Bash supports regular expressions by default and how to do it properly, and why you're so happy you learned extended regular expressions instead of just basic regular expressions. If you don't know what that means, go back and look it up. We covered it on one of the other weeks. I can't remember the exact week. All right, so that is what we plan to do today. Now, we've only got 2 hours, so we may not make it through all of that. And if we don't, we'll end early and then we'll do the other thing. Just a reminder, right after this is Go Programming Week number 2. which covers a lot of these same concepts from a Go perspective. And of course, every day for 2 to 3 hours, I do outdoor IRL streams. You're welcome to join me for that. We were trying out a new rig, just a little bit of an advertisement. We're doing a new WeBoost rig. It's got a huge antenna that comes off the top of my head. I was able to stream a remote mountain bike trail yesterday for the first time ever using the booster. So I'm really excited about that. If IRL streaming or going outside or watching IRL streamers is your thing, please make sure to check out that content as well. Thank you. Okay, let's get into it. So in Bash, we're coding in Bash. So let's open up something in Bash. We got our windows here. So you guys remember how to make a new program? Do you remember that? We made a program here called Greet, right? We made this program last week. So a little bit of a reminder. So here we have, you should know all this stuff, right? So this is what? Is this a function or a procedure? Trick question, right? It's actually both in Shell because the word procedure is dropped and people call functions procedures. So we covered that last week. Here we have a function greet, and it's running the RFC program without giving it any arguments, and then it's running the first and second argument is telling you the first and second. We talked about white space. If you don't understand the difference between $$ and $@, stop now and watch last week's video. How are you? And so what else are we going to do here? We are going to mess with this a little bit, right? So, and this is a moment where I have to pause because normally when I teach this in Python, I've taught it, over 12 years, and these little tiny mini projects, I call them mnemonic mini projects. We have been doing this exact project in Python for some time, and the project that we used to do was Bridgekeeper. So I can't show you that content because I'm doing this live now, but normally, I actually think we should do probably the Bridgekeeper project. I think it would be fun. And the reason I do it is because a lot of times I'm catering to younger audiences and they like to work in something fun rather than just the boring hello world kind of thing. And so pause the video right now and go do a search on YouTube and I will do it with you. Okay. Go to the YouTube and search for, first of all, go to YouTube. I like calling it the YouTube. It makes me sound old. Because I am old. So the YouTube. Hey, look, we're live on YouTube. What do you know? So yeah, let's look for this. Let's look for Monty Python. We used to do Monty Python a lot because Python. That's the namesake for Python, by the way, not the snake. Monty Python, Bridgekeeper. Okay, so. Monty Python, Bridgekeeper, Bridge of Death. Go watch this, right? Okay. It's really funny. I want to watch it right now. I can't pause the video myself. I would normally watch this with you. Okay, so pause the video and go watch this. And you'll get a good laugh out of it. If you haven't seen Monty Python, you need to watch it. You really do. Okay, so we are going to code the Bridgekeeper. All right. So... and I don't remember exactly all the things we used to do to code it before. I told you I fly without a net when I do this because I want to make the same mistakes as you. I also want to riff on it, make it different every time. So we're going to code the Bridgekeeper. So, and I'll just tell you what spoiler. So you better pause the video, okay? Because I'm going to spoil the video for you. The video has Monty Python and the merry band of, Camelot, the Knights of Camelot. They go to this Bridgekeeper who asks them, answer me these questions 3. Error the other side. You see, error means before, and so if you want to get to the other side, you have to answer the question. What is your what is the question? I can't remember. We got to remember. It's been a while. So it's like what is your name? What is your quest? And then some random question, right? Dot say, Robin, brave Sir Robin. What is your favorite color? Red, no blue. Red, no blue. What is your? I am King Arthur. I can almost do the whole thing. I'll probably get DCMA just for getting the accent right. Anyway, let's code it. Okay, so, and it's really fun. So just, Why should we do something crazy like that? Why even bother, right? And this is one of those things that some editing person might cut out because they think it's irrelevant. It's not. It's relevant. You know why? Because this is how memory works. Okay, I'm going to rant about this. Memory works by remembering things that are crazy. Yeah, we've talked about this before. I'm going to talk about it again. I'm going to talk about it all the time. The crazier the memory, the more it's going to stick in. People who remember pi out to like 60 characters in these memory competitions, you know how they do it? They make the craziest visual story in their head they can that contains every digit of pi. And then they play that story because our brains are hardwired to remember crazy stories. That's why we have really amazing dreams and stuff. This is how your brain works, okay? I'll give you this for free. So the crazier the thing, the more you're likely you are to memorize it. So are you going to remember Hello World? Maybe not, right? Because it's not particularly interesting. But you're going to remember Bridgekeeper because you're going to be like, oh, if statements are in that thing where we talked about Bridgekeeper. And you're going to associate that, and it's going to stick in your head better. That's why we do it. It's also the reason, by the way, that I'm just going to make a plug for the Head First series. If you're on Amazon and you want to buy any books, Head First, Python, Head First, whatever. If you want to read all about this entire mnemonic teaching approach, it is the basis for the entire Head First O'Reilly series. The reason these are so crazy and so dad jokey is because you remember those things. And you know what you don't remember? The really dry academic practical C or whatever, right? You don't remember that because maybe it has an example in there that you remember, and you remember it because of the example, but you don't remember it because there's no flowery language. There's nothing for your brain to grab onto. Okay. This is really well documented science of learning and education. Okay. And it just makes me sad every time that somebody puts this stuff down as being less than or silly, because it just means that they don't understand the science of learning and they haven't spent the time to understand it. And I have, and I've seen it work over and over again with individuals. In fact, I had one person, I'm going to say one more time. I had one person specifically come up to me and they say, thank you so much for breaking down these concepts by these little mini projects, because I now, for years, I came back and I could remember the one thing that I did about that one thing had it in it, and they remembered it because of its silliness. Okay, so it's not just because I'm old that I'm being silly. It's because there's science that says you're going to remember it better and you're going to learn it better. Okay, and that's all I have to say about that. Time to get on with it. Good morning. What are we coding today? No, Go is in 2 hours. We're coding Bash today. This is a YouTube video that I'm preparing, and so we'll try to keep it on the Bash topic for today, please. Okay. One of the forces is because human brain is more responsive to once upon a time rather than 143. Yeah, absolutely. People get this. Okay, so when that's all I'm going to say about it. I will say that I do get a little annoyed and frustrated at people who don't know this, who think they're know-it-alls, and they come at me and they're like, "Why are you being so lame about your teaching style?" I'm like, "This is actually science, believe it or not." Okay, you know what else? The more dopamine in your system, the more fun you have, the more you learn, the more it sticks. True story. Learning should be fun. This antagonistic learning thing where it's like, you're going to learn, I'm going to give it to you, and you're all stressed out. You got cortisol in your veins instead of dopamine. You don't remember crap. You know how I know? You know that time when you stub your toe and then you lose your keys and you drop your keys and you forget your thing and then you have a car and a bumper wreck? There's science that shows that the chemicals that are produced by the stress like that continue to gain momentum, and they actually cause you to do more things wrong and to forget things and everything. So the chemistry, the brain chemistry, is actually really a thing. So anyway, we are going to go forward, and so we're going to do Bridgekeeper. And there are a number of things we're going to do Bridgekeeper first. We're kind of already reorganizing some things, so we're not going to do repeating first. We're going to say different values. Okay, we're going to put that one first. So we're going to do if statements first. Sometimes, you can do repetition and if statements. They don't necessarily need to be one before the other. So we'll do Bridgekeeper. So let's make a new program. Remember how to do that? Remember? Touch bridge Bridgekeeper. We'll call it big long name. What's the science behind me losing my teeth in a bike accident and then getting rear-ended when driving? You know the rear end, the science behind me getting rear ended randomly. We're going to talk about it another day. What is the speed of an unladen swallow? I don't know. Bad luck, like bad karma. I mean, I pick your thing. I have no idea why I got rear ended. Yeah, it wasn't the same day, by the way. It was a different day. Getting cut off. Did you see? I almost got ran over the other day. A guy in a Honda Civic. If I hadn't been seeing him, he would have ran me right over. And then the neighbors all saw it, and they're like, "Oh my god!" Yeah, just don't go on a bike if you don't want to die on a bike. There was actually a really long time cyclist crosses the country multiple times. He's got I forget his name. He's from Florida. Semi truck in Wyoming fell asleep and squashed him onto the pavement. So if you're gonna, that has nothing to do. We need to work that into a lesson somehow. Almost ate the handlebars too. Oh yeah, absolutely. Did you remember that kid who turned like right into my bike wheel? Yeah. Okay, we got to stay on topic though, please. Thank you. Help me. Please help me stay on topic. Okay, we're coding Bridgekeeper. You want to make Python jokes? That's cool. Are you late? Yes, you're late. Yeah. So we got to stay on topic because we only have 40 minutes of the first hour, and we have 2 hours for bash programming. All right, but we have fun and we get silly. So if you don't like it, I told you this is probably not the content for you. Okay, Bridgekeeper. We opened a new program, and I didn't tell you what I did there. You should already know. Go back and know. This is why we make a new program every time, because it's good practice. Hey, what does the shebang line look like? I'm going to make the shebang line, okay? All right, look carefully. Watch carefully. All right. Is that right? All right, let's just start with that program. All right, what do you think? By the way, this technique that I'm using right now, particularly young people, they really love it. They really love what I just did. If you're ever teaching particularly young people as the authority who's up there doing it, you know what they love to see? They love to see the teacher screw up. What's wrong with this? Yeah, right? The bang should go first, right? Shebang, hashish, hashtag, bang, hash bang, shebang, 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 shebang. They remember my scripts more than proper teaching. They love it when you screw up. Oh, well, we won't screw up then. So obviously not a shell there, right? I've actually taken this concept too far. So one time I did an entire project and ran everybody into the wall on purpose. A really bad wall, design wall, and at the end of it I said, "See how horrible this coding approach is?" And they're like, "Wait, what? You mean we're not supposed to do it this way?" I'm like, "No, you're supposed to do it this other way. Let me show you that now." And all they remembered was the bad way. So don't do this too much. If you do it too far, they'll remember the bad thing. So, but it is occasionally fun to make a mistake and have them see that they know more than you. It's a good way to do the quiz without an actual quiz. You've been writing bash for 25 years and didn't even notice you did that. Yeah, well, you know. Okay, so that's one of the reasons I do. It's kind of fun. What's the difference between echo and printf? In one sentence. Line return and escapes. Seriously, what is the difference between here? I'm going to put this down here. What is the difference? I mean, there's lots of them, right? Between printf and echo. And the bottom line is, in shell, echo does not do shell escapes unless it's and POSIX compliant. It does not do it. There's no -e. So the short answer is printf does not add a line return. Echo does. Printf of course, has a positional thing, right? That's the main reason. And number three, printf will do escapes. So it will do line returns and terminal effects and all that kind of stuff. We're going to keep coming back to this one though. But echo is kind of easier. So people use echo tend to. They're both supported in echo is actually, and this is kind of a fourth thing. Echo is built into shell and bash. I don't think there's an echo command. Oh, there is. Okay, never mind. Take it back. That was wrong. So I guess shell uses echo and printf for separate commands, whereas in bash they're built in, which makes them more efficient. You may not care about that. It's just a shell script. If you're writing shell scripts, But that's one of the main reasons. All right, so what is the thing? So if we watch the beginning of the Monty Python, what is the first thing they asked, right? So let's say, I don't know, let's pretend like we're the bridge keeper. We're just going to start out with echo because it's just easy. We could say echo, you approach the bridge keeper. It's kind of a storyteller kind of thing. We could say, answer me these questions 3, ere the other side ye see. Okay. And I mean, we could probably have a colon there. All right. So let's see if our program works. So this, again, is just hello world in a different form, right? So let's run it. And should we make it so that it reruns it every time? How about that? Should we do that? Let's do our thing. Do you remember the command for this? How do I run a command every time something changes? Pause the video, see if you can remember. Here's the answer. ENTR bash -c. You can do shell too. And we're going to put in quotes. You can do single or double. Clear, and then we're going to run a program. So the program in this case is /bridgekeeper, bridgekeeper. All right, and then we have to give it on standard input. We need to feed it 1 file per line of the files to watch for the changes. And in Bash, we have the option of using the triple here and just typing the name that says send exactly 1 line to the input and make this be that line. And then we're going to put whatever. So the name of our program. So bridgekeeper. Keeper. Right. You could probably get cleaner with that, but now we're going to have some problems with this because we're going to actually have to get input from the user. So we're probably going to have to run them each time. Ooh, look at you go. Somebody got it. Nice. Good job. And so answer me these questions for the eyes of side C. So now we need to ask those questions. So I'm going to put a space here for no reason. What is your name? All right. So I hope you watch the video. What is your name? All right. Let's answer. Let's just add them all for now. What is your quest? Right. And then a third question that depends on who you are. Right? And that's a conditional. We're going to talk about that. So what is your, and what are the 3 different questions? Let's just put them all here. Did I do it wrong? Did I do my NTR wrong? No. Put the NC after NTR instead of bash. Oh, yeah. It goes after bash. But it's, the -c means run this as a script instead of opening up a script. Otherwise, it'll do a thing. You're going to see, though, that right away we're not going to be able to use the NTR, and I'm going to show you why that is. So we haven't done it yet, but we're going to be asking for input. Okay, so what is your quest? I'm trying to remember the 3 different questions, right? So what does the first person get? Who's the first person? The Galahad? Somebody know? Someone go watch the video and tell me. I can't do it because it's DCMA. So let's see. I'm trying to remember the first one. What is your quest? What is your name? What is your quest? What is your... I know one of them. One of them is the capital of Assyria. Which is he doesn't pronounce it very well. It took me forever to figure out that's what he was asking. That's what Brave Sir Robin gets. What is your favorite color? That's right. What is your favorite color? It's probably color because it's English. I'm guessing color. Oh yeah, yes, of course. How could I have forgotten? What is it? By the way, there's some really fun rabbit holes you can go in. There's actually a huge write-up of that answer. You can go find it out because the actual calculation of the online as well, and the answer that they gave in the show, which is a callback to the beginning of the show, is actually not accurate. It's pretty close, but it's not accurate. African, yes. All right. So what is the airspeed velocity of an unladen swallow. Well, as a king, you have to know these things, you know. All right, so I have to put all the lines in here. Well, as a king, you have to know these things. How do you know so much about swallows? I never get tired of it. I never get tired of it. It's so classic. How do you know so you know, you don't know why it's funny yet. You don't know why it's funny because you haven't watched it, but you better go watch it. Maybe pause right now and go watch the whole movie. Oh, you've never seen it. Quelle est ta couleur préférée? C'est comme ça, oui. Si vous voulez en français, oui, je peux, vous pouvez. You know what would be a cool side quest? To do this entire thing and detect the language of the person and then have it be an if condition based on their language. Wouldn't that be awesome? That's another use of conditionals. What? Yeah. You're like, what's a conditional? Okay, let's talk about conditionals. All right. A conditional is something that is done, steps that are done, at work that is done, actions that are taken if a condition is true. And so let's do one. Okay. So what is your quest? What is your name? What is your quest? What is the capital of Assyria? We're not going to do the read. We're going to jump right through the condition and then we'll do the reads, right? What is the capital of Assyria? So what is your favorite color? They don't get not everybody gets all of these, right? Right. We have these three that kind of go together. We have this one that goes together. So okay. So as you can see, they're all printing out. Well, we don't want that, right? So let's say that we have, for right now, we don't know the name. So let's just do this. Let's say name equals, let's just say name equals blank. We'll say name equals, Arthur. No, let's do name Sir Robin. Let's say Sir Robin. And obviously that's not enough, right? All right, this is gonna be a way to segue into regular expressions later, but we're not there yet. Okay, so name equals Sir Robin. All right, so if this is a conditional. All right, oops, we're gonna do it as okay. Now I have to decide that first we're gonna learn it in Shell, and then we're gonna learn it in Bash. Okay, so we're going to actually have two versions of this program. So the first one we're going to do with a single bracket. So you put the conditional in here, and it's if then, right? Phi, and we're going to leave it on the same line, but we're going to talk about why that's too annoying later. If name, okay, and since it's a string, we're going to compare it as a string. So it's a single equal sign, which is totally crazy. I know it does not mean assignment, and this confuses beginners all the time. The equal sign in this case does not mean equality, and we have not said that explicitly yet. But I have had to teach this many times. When people first see the equal sign, they think it means equality. That name equals Sir Robin. Like, what's going on there? And I have to tell them that in programming, the equal sign is generally used for assignment. I actually think it's really too bad that the equal sign was used for assignment. They should have used like an arrow or something. I mean, there are some languages that actually have like an arrow or something like this, right? And that says put Sir Robin into the name box, right? The variable. And we talked about variables last time and how you can't have white space around them in Shell. But that's what's going on. Okay, so but I don't want I have to restate this. This is put the thing on the right of the equal sign into the thing on the left. Now, the reason I have to mention is because when you put the same exact equal sign inside of brackets like this, it does equal equality. It is equality. And there's another version of it that has 2. And you're going to see, and in JavaScript, there's one that has 3, right? And they're all different levels of equality. So just get ready for that and somehow try to remember that. In our case, we're going to use an equal sign, and in Shell, it's even crazier because if you're trying to compare numbers, We're not going to get there yet, but it's a completely different equality operator. Shell is pretty whack. This is also why I didn't teach Shell generally to beginners. It's also why I prefer to teach Bash to most beginners. But as I said, we are going to do Shell and Bash right now. But this exact same line in Python, by the way, is if name equals is it EQ? I can't remember. I can't even remember my Python at all. I don't want to confuse you. All right, let's stay on Shell. So if name equals, now to be fair, it's almost always preferable to use strings in Shell. There's occasionally you gotta test for numbers, and we'll talk about that, but we're not there yet. In Python, it's 2 equal signs, right? Yeah. Okay, and then in JavaScript, you should always use 3 equal signs, which also checks the type, which we're not going to get into. Please don't try to explain that yet. We'll confuse the crap out of everybody. If name equals, right, Sir Robin. Obviously, this has problems. You can probably see with the first one right away. What if they type Robin? What if they don't capitalize it? Blah, 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 blah. And we're going to get there. We're going to get there. We're not there yet, right? Now, this is really hard to read, isn't it? So let's go ahead and indent this. Now, wait. Where did my keys go? Where are my keys going? There's no more keys. I want my keys back. My keystrokes. There we go. Okay. So watch. See that? See how it's 2? I'm doing 2 greater than signs. And I do set space list. And now you can see that is a tab. Okay. I use tabs in my shell scripts because tabs are officially the way to use shell. And you might not like it, but that is a fact. And I'm going to prove it later when we start to do here variables, which we haven't done yet. So, which only accept tab as indentation. So we're going to leave that to be a tab. If you are not using tabs and if you're a veteran and you haven't been using them, fine. But just know that is not, what am I doing? Why can't what am I doing? I'm having a brain thing. It's not unlist, it's unwet. I don't know, my fingers forgot it. Tab enjoyers win again. All right, so the main thing to take away from this is like set no list. There we go. My brain kind of forgot. This happens a lot to me. Is my fingers remember, but my brain can't think of it. I think that's the thing that maybe when you get old, I don't know. So I wanted to show that. But the other thing I want to show you here is that right now the error is giving me this expression, blah, 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 is on a variable. It's like, it's doing something wrong here, isn't it? What is it having problems with? Well, I just put name there. Let's actually see what that problem is. I can't read it all, so I'm going to do shell check. I'm kind of being redundant here so you can remember how to use shell check. So you don't know shell and you're reading like, okay, this expression is constant. Did you forget the $? Oh, yeah, I did. All right. Another thing that you get to laugh at me about. Wait, what? Did I not save it? I didn't. Oh, no, there it is. Okay. All right. So it needs $. Yeah, of course it does. In Python, it doesn't need $. In C, it doesn't need $. In Go, it doesn't need $. In Perl and Shell, it needs $. Yeah. All right. So here we go. We've got, so there it's happier, but it's still rolling his eyes at me. It says double quote something something word splitting. Can't read it because I'm on this big ass font. Whoops, I swore. For you, that's for you. Normally I don't do that. So let's go look at double quote to prevent globbing. Why would I double quote here? Okay, so this is really important that you understand this. All right. This is where shell gets really unsafe. This is the reason we're running shell check. So I'm going to spend 5 minutes ranting about this. Okay. Everything that happens between there, it's almost impossible to remember when expansion happens and when it doesn't, right? And we haven't really talked about expansion a lot. We did touch on it briefly with the little glob star expansion. There's multiple forms of expansion that can be done. And by leveraging expansion, somebody who can run your program can make your program do things that it's not intended to do by passing. So say, for example, name we're being passed in as an argument, which in our case is going to be, right? It's going to be prompted by the user, so that's not safe. User can type whatever they want, right? They can type a little bit of code in there and have it replace name with all of that, run the code, and then behave as usual. That's called an injection attack, okay? And there's SQL injection. There's all kinds of injection attacks. It's like a stalwart of the hacking community. And Shell is notoriously bad at keeping you safe from injection. Okay, and I want to show you one quick difference between Bash and Shell at this time, and one of the reasons that I believe Bash is a safer programming language than Shell, and you can make a decision for yourself. But if I change this exact same program to use Bash instead, okay, bin bash, right? First of all, you're going to see that error is going to still be there, okay? Okay, so that one is not fixed necessarily. The single bracket in Bash behaves the same. I see people write Bash code all the time that says bin bash at the top, and they don't take advantage of what I'm about to show you, and it just makes me crazy. Because there's no reason for you to write the unsafe shell syntax single bracket if you are using Bash. If you are using Bash, by default, you should automatically always use double brackets, because that injection attack just stopped being a possibility because you used double brackets in Bash, which shut down all of those insecure ways to use conditions. All right. There's at least one veteran out there who did not know that, who just learned that today, and they're not going to admit it. But I'm telling you, if you are writing Bash and you are putting single brackets in your code, you're doing it wrong. You're unnecessarily making your code unsafe. And if you're not running shell check, you're not running shell check, you're not going to catch those conditions. Now, there's a lot of safe code. The code runs fine and it's not insecure to do the single brackets in Bash. But why? Why? Right? If you went to the problem of forcing your entire code to be completely incompatible with POSIX shell because you made it bin bash instead of bin sh, which forces it to use bash every single time, why not take the advantage of double bracket conditions in Bash? Okay, so I'm going to put that down in my little notes here. Why should double brackets always be used in Bash? Okay, so this is kind of a little self-help, self-test you can go through. You can ask yourself. And let's see. Okay, we'll put that here. And so now you know. Okay, you see that I did not have to quote this. Why? Because expansion is impossible in double brackets. In fact, let's go read it in the Bashman page. Rather than take my word for it, okay? I really want to spend a lot of time on this because this is about safety, and a lot of you are starting out learning coding, and I want you to do it right because so many veterans. I guarantee you, beginners, you're going to see people that have been coding shell for 30 years, and they're going to have these sometimes they'll write, you can run it through, it won't even pass shell check. I cannot tell you how many times I have taken production code that runs as root and run it through shell check and found multiple security vulnerabilities in it because nobody even bothered. And when you bring it up, they're like, what's shell check? Because there are a bunch of old timers who have no idea about modern shell scripting. Now you know. All right, so man bash. So let's go down and read this. This is a really big man page. You don't want to read the whole thing right now. But let's go do condition. Let's go search for condition. Condition expressions. Okay, so conditional expressions. We're searching for that. There we go. Conditional expressions are used by the double bracket compound command and the test and single built-in. Okay. Okay. So this is a kind of an interesting remnant. I don't know if this is now the time to tell you, but don't let me forget. I'll tell you right after what's going on. Why is test and single bracket mentioned in the same breath? I will explain that in like 2 minutes or so. But let's talk about why double bracket and why they list it first. To test the file attributes and perform string arithmetic operations. The test commands determine the behavior based on the number of arguments. See the description of the command, blah, blah, blah. Okay, so, all right, so expressions, it's talking about what goes inside of there. This is what I'm trying to show you here. So when used with double brackets, the less than and greater than operators sort lexicographically using current locale. The test command sorts using ASCII ordering to keep it be POSIX compliant. So I don't know that all this stuff we'll get to this later. This is detecting what file type. We don't need to do that right now. That's too much stuff. What I'm looking for is this. Okay, so here are the operator condition, the comparisons. So true if strings are equal. Equal should be used with the test command for POSIX conformance. Again, if you're writing shell, you know it's different, right? When used with the double bracket command, this performs pattern matching as described. So we're going to talk about pattern matching. I'm trying to get to the part that it tells you that it does not do expansion. Okay, when a simple command is executed, the shell performs the following expansions. Blah 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 blah. Left. Let's see. If the search is no, that's not it. Set a rule based on. I don't think it's going to tell us. I don't think it's going to tell us here. I don't remember where it is that tells us, but let me just tell you so we can move on. Double bracket does not perform expansion. Okay. So that is the answer. Double bracket does not perform expansion. And this is going to help you understand regular expression matching, which we're going to do later today, hopefully. What time is it? Okay, so yeah, this is a little bit different than live. So Weep18 is available on YouTube. It should be. It should definitely be on YouTube. It's under live. It should be grouped under the. If I haven't, I might have to list 18 on the podcast. It might not get listed on the podcast yet. I apologize for that. Now everything's live now because it's just easier. Okay. So we're using double brackets for bash, single brackets for shell. And again, we're using shell check if we can't remember. So I'm going to go back to POSIX shell, and we're going to stick with POSIX shell for our first version. And we're going to change the whole thing to bash later. Okay. But now you know the difference. All right. So how do I make it safe if it's shell? Well, it says what to do. Put brackets around it. All right. And that allows, if there was a string in here that had a star in it or something fancy, it's now immune from an injection attack because single brackets, otherwise known as the test operator, do not do that. So let's spend 5 minutes talking about what's up with the word test and the left bracket. Okay. You might have to pause the video right now and take a breath because I'm going so fast. Hey, how's it going, YouTube? So the reason for this is one that's historical. So I'm going to explain the difference between POSIX shell and bash and the difference between subcommands and built-ins. Okay. This is very specifically a shell thing, but it is critical that you understand this. Okay, for lots of reasons beyond performance, particularly because of security. All right. We already talked about how programs that are in your path, in case you're wondering, this is what my path command is. We're going to do, this is a parameter expansion, which we will do later today if we get time. But that's how I'm doing that, just so you want to know. These, in their order, are checked for the existence of a command, and the command is run from that location. Right. And you'll remember from previous weeks, the command which will tell you where a command, specifically an executable, that is a file that has the executable bit set, whether it's a script or a compiled program. And if you want to do compiled programs, an introduction to that, watch the Go thing later today. So we're going to do which, and we're going to say like ls, right? Well, if you do which test, you'll see that there is a program, right? And you can actually do you can do file user bin test, or if you don't want to type like that, you can combine those two things that I just did like this, which you already know, file backtick which test, and that will replace the backticks with the output of the command. It's called a subshell. We're going to hit those again, but those are very convenient. In fact, you can use this technique to do all kinds of fun things. So if we wanted to see what ls is, if we wanted to see what links is, we see that links is a born shell script. Okay. If we wanted to see what, let me think here, htitle. Htitle is a born again shell script. Okay. You get the point, right? So you got these files that exist. So what's up with this? Now this one's going to blow you away. Okay. File which left bracket. Yeah. Is that just crazy? Check this out. Type left bracket. What? All right. So I'm going to clear the screen because I really want you to understand the difference between these two. Okay. If I do file which left bracket, and you can see that there is actually a file called a left bracket, then the name of the file, and that file is executable, right? ls-l which left bracket. You see that it's owned by root. Anybody can run it, and it's a binary file. Okay, but that is not the thing that gets executed from my shell right here. What is? That's what type is for. It's really important you understand the difference between type and which. Okay, and command-b actually. So we already talked about this in the previous week. So type, you do type and then left bracket, and it says it's a shell built-in. Okay. Yeah. Oh, that's very nice. So thank you for that. Yeah. Okay. So look at this right here. This is super interesting. Here we see that the left bracket is two different things. What is going on here? And that's what I want to explain. So anciently, and actually let me change my running interactive shell to be sh dash or sh, right? So file which dash which sh is symbolic link to dash. So when I run bin sh, I'm actually running dash, and dash is a POSIX-ish shell, which means it's not bash, right? And that's what, most of the system shell scripts are written in that to be more efficient. The Debian project moved to dash. Alpine uses ash, I believe, instead of bash, because it was smaller, it was lighter weight, it started up faster. This is way before they went to systemd, which really sped up, start up any faster than that. I don't want to get into it, but that's, all right. So what's up with this? So imagine I was running dash or even k shell as my shell, right? So let's do that. If I was running, we're not, right? It's stupid to run this as an inactive shell because we don't have anything built in, and a lot of reasons. But let's pretend for a second. So how do you run another shell? Well, you just run it, bin sh. Now I'm the shell, right? And all of my stuff is gone. Actually, this is actually one of the reasons. You remember I said, we haven't talked about this yet. But we're going to talk about, well, we're going to take all this bash knowledge and we're going to make our first bash RC, and we're going to make decisions along the way about whether something should be an alias, a function in a bash RC, or it should be a standalone program. And because I've made so many of these one-liner type of, 3 or 4-liner shell scripts in my scripts directory, my .dot files, those things are available to me no matter what shell I'm using. I could be using tsh shell. I could be executing them from Go as syscalls. It doesn't matter because they are standalone executables, even though they're only a few lines, and most people would put those in their bash RC functions or someplace else. I choose to maintain a rather large collection of little teeny tiny scripts rather than have aliases because they work everywhere as filters from VI, called from Go or whatever. And as you just saw, my path program still works. If that had been an alias, it wouldn't work, right? Or a function, it wouldn't have worked because shell doesn't have functions and aliases. I mean, it does have functions, but not the same. It certainly doesn't have parameter expansion. I mean, we know that, right? So let's get back to the point. So the point is, now what, right? So I've got, everything else is interactive. I don't get my colors because it's, it's really lightweight shell. But now check this out. So the whole reason we came here, we still have this. Now we type, which is supported in both shell and bash. We type type, and then we type bin. I don't remember where it was. We can still do this. So which bracket? Okay, so it says user bin left bracket is user bin left bracket. All right, and something that's interesting about this is if you actually run file on this, user bin left bracket, and then you do file I don't have my completion. My history commands are all gone because, right? Tests, right? These files are almost identical. In fact, let's do, shoot, I can't do it. ls-l, which left bracket, and ls-l, which test. All right. So we see here some interesting things, right? I was expecting maybe to see a hard link here, but there's not. There's not a hard link. So those are two separate identical files, which are actually, no, look at that. They're not even the identical files. I didn't know that. I'm learning stuff here today. You locked yourself out of team. All right. So here we go. We've got 51632 and 43440. Actually, let's put an H in that. I can't repeat. I can't. The shell history command, does that do this? No. Because I'm not using an interactive shell. LH. Which, all right. So there we go. ls-lh. Whoopsie. Which test? Well, I was trying to show that these are the same thing, but they're absolutely not. They're not. I was expecting to find them to be hard linked. They're not. In fact, look at that. The left bracket command is actually bigger than the test command, even though they're supposed to be the same thing. I find that absolutely fascinating. There's at least one old timer who just saw that and is like, what? All right, let me repeat something here. The test command, these two user bin commands, test and left bracket, are not used in bash unless you explicitly write user bin / left bracket. And why would you do that? Nobody does that. They are not used. That is the takeaway. The takeaway is, just like printf and echo, that left bracket and test are, number one, they're commands. They're not part of the syntax, you know. They're actual commands. In fact, it's really kind of funny to read about the left bracket command. Check this out. So test expression, right? It's telling you that that's an expression. And by the way, this is the reason there has to be a space before the closing bracket. No, I'm not even kidding. So these are some really esoteric shell things, but they're kind of cool. They're kind of cool knowing about them. Yeah, I'm going to go out of here because this is really annoying. So let's do this. Man left bracket, right? So first of all, you can see that the test command or the left bracket is a command. I mean, this is the man page. This is not the help in from bash for the built-in. This is actual stuff. This shows you they're the same, even though it's not the same binary. One of the binaries is bigger than the other one, which is really interesting because the man page is the same for both. Okay, so the thing that's super interesting about this is the way the shell processes this. This is the normal way you would think of a command to be processed. It passes a bunch of arguments. But in the case of test, when you use the left bracket, it tells the program to wait for an argument that is a left bracket. So this right bracket over here is actually an argument to the left bracket program, which is effectively the same as test. Isn't that weird? Isn't that weird? The left bracket is actually an argument, and that is the reason you have to have a space before it. Because if you don't have a space, it becomes part of the previous argument. How many veterans out there have always wondered, why do I have to have a space? This is so annoying. And I guarantee you, if you're a veteran out there, you've been programming and you've accidentally left the space out, and you had to go back and change it and put it in. It's been annoying. Like, why the hell does shell make me put a space there? Because the last bracket is not part of the conditional syntax. It is an argument. That's the reason. So that is why that's so weird. And so they just had to maintain that weird backward compatibility. Now, if you're learning how to code in Bash or Go or any JavaScript or anything, you're not going to have any of these problems, right? Because those are actual languages. And you're like, why are we doing shell again? A reminder, the reason we're doing shell is because it's the first language you're already coding in. As soon as you logged into the machine, you were coding because you were already coding in shell. Might as well learn it. And a lot of people don't. Yeah. That is pretty WTF. I agree. But that was because shell was one of the very first, if not the first language made besides C. I think, I'm talking about Unix, right? So first there was First, there was C, which was created to make Unix. Fun fact. The first version of Unix was written in assembly, and the C language, Ritchie and the gang, created the C language to create C. I mean, to create Unix. It wasn't an extra project. It was specifically to create Unix. So C is inseparably tied to Unix and Linux and always will be. People that talk about getting rid of it, I'm not going to name names, foolish statements. C will always be with us. C was created to make Unix and Linux and will always be there for that. There's going to be lots of other languages come along that are going to help us make different types of tools, maybe even kernel drivers. But C is something definitely worth learning and understanding. Syscalls will always be in C. Those can't be rewritten. Right? They'll never, ever, ever be rewritten. So when people suggest that the kernel is going to be rewritten eventually in some other language, they don't know what they're talking about, because that would mean redoing all of the syscall languages and making essentially a brand new operating system. And that might happen, but definitely not replacing the language that was written in the kernel that was written in C. So C was ready to make Linux. That's what I'm trying to tell you. So those are two very important languages to learn. Okay, let's go back to the fun stuff. All right, what time is it? We're going to take a break here in 5 minutes, and I'm going to take an actual 5-minute break, and there will be a pause in the video, so you'll have to fast forward on that, just so I can get a drink. Cobalt's not going anytime soon either, no. Yeah, so we use the single bracket, but remember, bash, it's not, if you're using bash, once again, just a reminder, the left bracket, it's a built-in, which means, okay, one last thing. Whenever you run a command, there is a subshell created. So the program starts a program underneath it, and then that program runs and completes and comes back to the main program, and then everything keeps going. And we're going to talk a lot more about process management and how they run, and we're going to show you all that later. But it's important to say right now that when something is built in, there is no subshell. There's no sub-process. That's the precise words for that is a sub-process. A process is a running program, right? A subshell is implied, and sometimes people use the word subshell incorrectly there, and I do too, because it's another shell that's running under the other shell. It's actually just a program that is running under the management of the parent program, and that is a sub-process, right? You can call it a sub-program or what, but sub-process is what it's called. And by the way, you can see these anytime with PS. If you install PS3 on your computer, you can see this relationship between all the processes on the system. This is a really quick and dirty way to show you this. Why am I not got color? Where's my color? Where's my color? Anyway, so here you can see systemd is the main process, and then all these other things are children of that process. We're going to get into that later, but it's worth just mentioning it now. So if you want to go down that rabbit hole on your own right now, you can. About C being created, 100% true. Yes, it is. I know that because I watched a documentary. Every Christmas we watch a documentary, The Making of Unix, which is absolutely hilarious. It's put on by Bell Labs. It's really hilarious. We do kind of a Mystery Science 3000, and we just watch it together, and they talk about some of that stuff. I think that's where I heard it. I can't remember. So anyway, what is your request? The name is Saraban. Then what is the capital of Syria? Okay, so we've got our sub. Now this is a subshell, right? Which is not as efficient to do that, but we don't care because it's just this thing. All right, but it's really still not right, is it? I mean, when I run it, what is it doing? It's printing out. Actually, let's take a break right now, and I'll come back. We'll come back to this and jump right into the logic. I know I went down lots of rabbit holes there, but they're essential rabbit holes for you to understand, and they never talk about them when they teach Shell, if you're lucky to even be taught Shell at all. All right, so we're going to take a break, and I'll just stop talking for a bit. I can't put music on, so go find you some music, and I'm going to put a term down. So how long should we be? Term down 5 minutes. How about that? I only need 5 minutes or so. Term down 5 minutes. Alrighty. Oh, hey, should we make it colorful? Little cat. How about that? It's not as colorful as it could be. All right, we'll talk to you in a bit. All right, we're gonna get going back again. I got stuff to do today, so I'm gonna stay on time. All right, so after a lot of side quests and rabbit holes about this condition and test versus left bracket and if statements and all that, we're back to the conditions. Just so you know, we're skipping all of the many things you can do with test and inside of this thing. We're only focusing on string equality right now so you don't get bogged down. There's so many cool things you can do inside of there, and I don't want to overwhelm you with all of them right now. We're going to incrementally add things to that list as we go. Okay. Sound is fine for you? Yeah, please let me know if you have any problems. Is the sound bad? Is it because I'm talking too loud? I moved the mic or something. No. Oh, you retired browser? Okay. Alrighty. So here we are. And we've got this condition. So if the name is Sarabin, but as you can see down here, the program is running. It's putting what is your name? What is your quest? Obviously, we're going to have to prompt for that. And I want to get through that today, if nothing else. What is your favorite color? What is the speed? And how much do you know about swallows? So, so as you can see, because we set the name to be Sir Robin, it did all of it, right? But what if we change the name to take an R out of it? Oh, look, it didn't ask that one question anymore, right? Okay. So we can, well, who gets this one? Let's just copy our code, shall we? And let's kind of make it so it fits on the same screen. Moving it over. What is your favorite color? So, what is the capital of Assyria? So who gets the favorite color thing? I want to say it's Galahad. No, it's Lancelot. Lancelot. Right? So it's Lancelot. All right. So I can't. Yeah. Sir Lancelot. If you get stuck with an ad, by the way, if you get stuck with an ad, just know that the stuff's on YouTube, so you can go back and watch it. If the name is Lancelot, what is your favorite color? Now notice that down here it went away, right? The favorite color one is now not there. Well, let's keep going here. So all of these questions, these last three questions of this dialogue, is only for King Arthur, right? So let's get rid of Sir for that matter. It's just too hard right now. We'll just put Robin just for the sake of programming, and then we'll make it fancier later. So now we have phi down here. Move these over and save that. All this VI stuff that I'm doing is all covered in the VI lesson. Go watch that. Practice. And as you can see, the stuff that the output is considerably lessened, right? We can change this to Arthur. And so what is your name and what is your quest? Everybody gets that, right? But if we change Robin to Robin, then Robin gets Assyria. Arthur gets those ones. And Lancelot gets, what is your favorite color? Okay. And we haven't talked about how to read the input yet. We'll focus on that, I promise. But I want you to see that these are all happening, right? But there's something happening here that you are not seeing. And I kind of want to show you that, okay? So every one of these conditions is being evaluated. Okay, so let's step through the code, which is exactly what the interpreter does, the shell interpreter does. It goes through every line. It says, answer me thing, okay, then it prints name equals Lancelot, okay. In fact, if you want to see all these lines, time for me to show you set-x. All right, so let's actually run this in a separate window. Let me turn that back on. But in another window, in my case, it's a C, but whatever. So now we're in another window. We're in the same place because I started my tmux from that session. We covered tmux in another session earlier. And I'm in the same place. And let's actually run that program. ./bridgekeeper. And let's run that now with the set-o on. Okay, I mean -x. So this is actually something about shell that is rather unique. I mean, there are debuggers in other languages, but this is relatively easy to turn on. And what's so cool about this is that when you turn it on, it only applies to the scope of the function that you're in. And in this case, it's the whole program. So if you're having problems with this, like the whole program, great. But if you're having problems with a single function, you can set this thing inside of that function and have it just affect that function and show you what it's actually doing. So when you're trying to figure out what's going on, as I was about to go trace the steps, by one, but that's exactly what set-x does. So it says echo answer me these questions 3. So this is the program line that it saw, and then you see it come out. So that's the step there. Another step here. It sets the name to Lancelot. Doesn't tell you about it. Just shows that that's what happened. Echo is your quest. What is your quest? And then it tells you what it evaluated. Okay. What is your quest? Lancelot equals Robin is false. Lancelot equals Lancelot is true. Therefore, it runs echo your favorite color, and then it does a favorite color. Lancelot equals Arthur is false. Okay. And false and true, by the way, are what? What are they? Do you remember from last week? Pause the video. False is, and we get this right, I always mix them up. False in shell is anything that's not 0. And true is 0. Great. Okay. So if you were to look at the numbers, so any one of these lines that evaluates to true or false, that's what's going on there. Okay. But I wanted to show you that. Okay. So now we can actually turn set-x off. All right. And it'll go back to normal. But okay, so let's dive into the final thing for today. How do we read input, and how can we combine these conditions? Okay. Let me go back to the set-x thing. I forgot the reason I did that was I actually had a purpose, I promise. All right, so it's clear. All right, so what do you see here that is being inefficient? Why is this logic, the step-by-step logic, what is inefficient about it? Pause the video. Why is this code unnecessarily, it's bad. It's just bad code. Why? It'll work, and nobody's going to call you out for it because it's probably not going to be something you're going to know about, but now you'll know why. Why is this code not as good as it could be? And it's not just the code, it's the logic, okay? And that's why I turned set-x on, because set-x shows you what is being evaluated, all right? Why should, exactly. So when it asks, when it says the name equals Lancelot, right? And it goes Lancelot equals Robin, and then it says Lancelot equals Lancelot, that's the one that's true, right? Wouldn't it be cooler if we could have it stop there and not ask if it's Arthur? Now, there are conditions under which you would want to have multiple if statements. Let's say you want to do something else, and then you wanted to have another set of conditions based on the person, right? But there's another way to do this. There's a way to combine this logic, these conditions together, right? And that is elif. You could also do case, which we're going to do in a bit later. I don't remember my elif. I never use them. There we go, elif. All right, so this is else if. Languages, and we can kind of put these together. We can change this elif to this, and we can combine these ifs into an elif. All right. And now we can maybe do this. I don't know, whatever you want to do to make it easy to read. So, yeah. So, but what I want you to see is, even though that does not look that different, it's very different. The logic is very different. And as you can see now, okay, so this is the previous one, right? Let's run a new one now right here. So you can see that it went to, what is your quest? Robin equals Robin, Lancelot, and then it did it, and then it broke out of it, right? It broke out of it, and it didn't wastefully check for Arthur, okay? Switch case for a condition that has more than 2, yeah. And so since, my stream, people love, showing off that they know better ways to do things in advance of when I want to cover it. So I'm going to have to cover it now because somebody mentioned it. Okay, so in Shell and Go and C and not Python and in JavaScript, there is another way to do this. And be really careful on the words I pick here because I don't want to confuse you. So let's exit out of here for a bit. So this particular thing that we just did has a very specific additional syntax, and I'm going to put that here. Brackets set of feet. One more times. Is he? Limit based on values. What are conditionals? How can I combine multiple conditional checks? And that's what we're going to do. Okay, so we already looked at one method of combining them: if, elif, 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 elif. And if you have Python, by the way, that's your only option. There's a huge fight in the Python community, by the way. When did it add it? Did Python add it? No. Did Python finally add a switch statement? I don't think they did. That's not. Well, we're not talking Python right now. Right now, we're learning about Shell. So there is, in the new version, it has it. Oh, wow. Cool. They finally gave in. They finally gave in. Okay. So, yeah, it wasn't in 3.11. I know. Okay, let's not talk about Python for right now. Case, right? ESAC. And I'm going to have to look the syntax up for this because I can't remember off the top of my head. I always have to look it up. It's very, very weird. And so I think it's actually a colon. Let's actually read about it. Help case. Here we go. Oh, case word in. Yeah. All right. So case name in. Okay. And then you have all this other stuff, right? And we have that down here. So instead of having else if, we're going to put these brackets around here. And we're going to have Robin, colon, and then you have the things you want to do, and you put a semicolon at the end. You have to have 2 semicolons at the end of, and I will talk about why in a little bit. Okay. I'm trying to figure out how to convert this fastest. I suppose this is fine. We're joining those lines. But you're going to see that we're going to need to do some more stuff here in a bit. And it's usually traditional to do that kind of thing, but you can do what you want. Doesn't matter. That kind of style is up to you. I haven't done anything about it yet, but you don't actually need the quotes. Let me prove it to you. Okay, so, here we have an issue. We have multiple lines, right? All right, so the way to do this, because this is all technically one line, and this is one of the reasons people put it like here. It's going to want one of these, I think. Actually, I don't think you do need to do that. It might. No, you don't. All right, so that only needs 1, and this needs 2. All right, so, yeah. So, yep. It's going to tell me this is probably it needs to be quoted. So that still needs to be quoted because of shell expansion. And let's see. I'm pretty sure we can get away with this. I don't write cases every day, so I might be getting it wrong. You can see me get it wrong. There's the if statement. Okay. All right. So let's push our luck here. Now that is cleaner. That is definitely cleaner. Thank you for the Python information. Oh, look at that. You didn't even have to escape it. So that's cool. I just learned something today. So the case statement in shell is not expanded. We don't need setx anymore. Let's delete that. We can add that later. So the case statement, as you can see, is doing the same thing as the if statement, but it's a lot prettier, right? Something's cool here that I'm not going to break into right now, but you can actually put multiple values here. And you can use wildcards and a bunch of other things. In fact, this is one of the only ways to do pseudo regular expression matching in a conditional statement, which I don't know if we're going to have time to get to today. Yeah, we might. Okay, so there is something really cool, though, that we skipped. Yeah, we skipped it. Damn it. We forgot else. Yeah, that's what Code Pill. Stop saying what I'm going to say next in advance. You're like stealing my thunder. All right, so yeah, you're kind of leading us along into that space too early, because we can't really do it without a dummy mommy machine. All right, so but see, because they don't know the version of that in if statement. So we kind of left the if statement a little bit early. So I'm going to comment this code out, and you want to see how I'm going to do it? Watch. I'm going to do exclamation point there. All right, so exclamation point, right bracket, that goes all the way to, actually no, let's do exclamation point capital G, that goes all the way to the end of the program. I'm getting rid of the exclamation point though, because I don't want it to run something on the command line. I want it to send all of those lines to something. We already did this with VI. I'm gonna put some stuff. Now you can do this in visual mode, but I'm doing it in the VI standard mode. Okay, replacing the beginning of the line with a comment. And a space. All right. And then we're going to hit enter, and that will comment out that code. Okay. Now Lancelot doesn't have anything to do now, so it's having trouble with Lancelot, and it's still trying to highlight all that. I don't want to do that, so Control L will turn off the highlighting. Okay, so we commented out that code, but I want that code to be there because I want you to see the other way to do this in long form, and I'm going to rewrite this code. So we're going to say if name. Remember, I'm going to try to, this is a good review. If name equals Robin, all right, then, and we can put this one here, and take that off. And do we have two tabs there? Let's get rid of one tab. Okay. And we don't need these semicolons, even though they're fine. So let's put 5. All right. If name equals Robin, why is it mad? Oh, because now we haven't set it. So let's go set it, and then it'll stop yelling at us. Okay. So if name equals Robin, and then elif name equals Lancelot. Elif name equals Arthur. Okay. And we have a lot of conditional checking to do here, but there's nothing here. The reason it's barking is because there's no line there. And we're going to put that there now. So we'll put this here. And we'll put what is your favorite color. I'll put these 3 lines. So I'm building back the elif statement because I kind of prematurely deleted it because I wanted to show you something and I forgot. So that's related to what Copil was talking about, but that's what he's talking about with the case statement. They're talking about, I don't know their gender. All right, so let's get rid of these. We don't have semicolons here. The semicolon is necessary in the case statement. By the way, the 2 semicolons means the end of this grouping, right? And a single semicolon means the end of this line. And you have to have one, I'm pretty sure. I don't think you can have it be on a separate line. I don't know. We'll try that again. I always go back and forth on that. It's generally a good idea to put a semicolon there anyway. Because technically, I think that is all one line, and the semicolons have to be there. I've always put semicolon there. Anyway, it's a little weird because you don't need semicolons on other things, but you do that, right? Set no list. We don't want that on anymore. All right, so, well, you had to know this game. Okay, so. Now, what if we want for everything else? We can say else. So we can add an else. So you can limit it to 2 conditions, and the else is else, right? So the first condition is the true stuff, and the second one is if it's false. And in this case, we're actually combining it, and we're also adding it. I should have probably covered that first, but hey, how's it doing? So what do we want to do? What is your favorite color? I think pretty much it's not just Lancelot that got your favorite color, because Galahad gets the same question, right? Galahad gets the question, goes blue, no, and gets it wrong, right? So this is really not just for Lancelot. This is for everybody. All right, so let's give it to everybody. That's the default, okay? And we're going to delete Lancelot's question. So now if we run a program, let's see here. So let's run our program. So /bridgekeeper, bridgekeeper, and we get, what is your favorite, what's your name, what's your favorite color? Okay, everybody gets that. And that is because the name is Lancelot. If I put the name is Rob, all right, what do I get? What is your favorite color? It's the same thing. And it is this is probably a good time to introduce how do you ask for somebody to type something in, right? Probably a good time to do that because it's annoying changing it in the program every time, right? Now, we already talked about how to pass an argument. But because this is sort of an interactive story game, we actually want to prompt the user to type something in and read from standard input. So this is new. And I'm going to put it in here. How to repeat something more than one time. How do you do the works in place of bash? How do how do I prompt the user to type something in? Data input, standard input, right? And so how do I do that? Well, there's a program called read. Okay, it's a program called read in shell. We're doing shell right now, but it's also a built-in in bash. And if you don't know what that means, rewind the video and go watch the whole conversation about test versus left bracket, right? Double bracket versus single bracket, because we talked about what does it mean to be a built-in versus a command. And shell uses commands, bash uses built-ins, often which are the same name. Printf, echo, test, all that. Okay, so read is one of these. Let me prove it. So type read, built-in, right? If I run shell, type read. Oh, I learned something today. Dash read is built into the program. It's not a separate program. I was wrong. I'm glad I tested it. So that's good to know. So read is built into dash. Yep. There's no such thing as a file called read. So read is always a built-in, whether it's POSIX shell or not. Okay, good. As I said, sometimes the things are built in, sometimes they're not, and now I just learned something. So I was wrong. This whole time. Yeah, it's yet another thing that I'm learning with you. Anyway, so let's go back to bridgekeeper. Okay. Wait, what's going on over here? What is your favorite color? Okay. So we want to read this value in. So here's what you do. It's pretty easy. Read name. All right. Now, there's going to be a problem here, right? There's a problem here. And it says it's I want to show you that it still works though. Okay. And then we're going to fix the problem. So bridgekeeper, answer me to question 3. What is your name? Rob. What is your question? Okay, so as far as we know at Reddit, we don't know though. So how can we do that? Well, let's just echo something. It's like, you entered, name. We're using echoes instead of printfs, for now. And we talked about the difference before. Name, Rob. You entered Rob. Okay. And what is your quest? So enter. Okay, now why is it yelling at us, right? Because we're reading a variable without some magic, okay? And in order to understand that, good old shell check, bridgekeeper, it will do it. Read without -r will mangle backtracks, okay? So this is something you should just by default always add it, and in shell. And I know this is one of the reasons that people don't like learning shell as the first language. It's like, what? That's like a really esoteric weird thing. It's true. You should always do read-r, right? Very, very rarely do you want it to not do backticks incorrectly. You want it to read the backticks. You want it to read the actual data, or the escapes, or not do the other thing. So that's going to make that go away. And you would only catch that with shell check if you're a beginner. So that's one of the reasons to do that. And I keep saying this over and over again, use shell check as a beginner. You entered name, all right? And now we do shell check bridgekeeper, and well, we don't get any errors. And we go ahead and run it, and say, what is your name? Rob. And you entered Rob. What time is it? We have time to do color? I think we do. We can't do all the color, but we can start color. We have 30 minutes. Good. We're going good. We got good time. All right. Now, before we leave read, we're going to be using read a lot. Okay. What does read do? All right. So if you want to read about read, apparently you can't do man read. You got to do what? Okay. This is good. You saw this. This is the read. See how it says read 2 up here? This is the man page for the read standard library for C, which man pages of which come on every single Unix system, Unix or Linux. So that is not what you want. The reason that's there is if you're looking at syscalls, read is one of the syscalls, and you would see this a lot. So that is just stuff to put aside, and if you're going to go into operations, you need to know that. But you're like, that's not what I'm using. So that's because you need to do help read instead, because read is a built-in. All right. And I learned that the hard way the first time today by doing, man read didn't see it, and doing type read, and then it showed me what kind of thing it was. So here you can read all about it. This is the section from the man page if you want to read it in a cleaner way. So this reads from the standard input. So we've talked about standard input redirection a lot. You can probably guess already what happens if I wanted to not have it read the name. What if I want it to... by the way, why didn't it run the command there? Make sure you know. All right, so what is your name, Rob? What if I do this, though? You remember how I told you can send one line of standard input with the triple, like we're doing? Yeah, look at that. Pretty cool, huh? If you have multiple lines, though, it's a different story, right? We're going to need to redirect a file. This is one of the cool things about shell in general, is that when it's reading from standard input, it'll read the standard input from the interactive terminal, but you can also redirect that from a file. So there are many applications that have a expected order to their lines, or they just read a JSON file or something like that, and they read it from standard input. So you can redirect all of your responses and everything directly from a file, and the program will behave based on that. And we didn't really have to do anything to the program to make it become non-interactive. We just had to send it data. I think it's important to say, and I'm going to put this in the Vim, when and why would you not want to prompt the user? Okay, when we're making these interactive programs, I think it's really important that we talk about this, because people leave making interactive programs and they think all the scripts should be interactive. I think right now, pause the video and let's talk about it. If you're in the chat and you want to suggest something, go for it. When is a time when you would not want to prompt the user? And I've seen this code in production and enterprise all the time, and it causes all kinds of problems. And so pause, here's the answer. The answer is, pausing to read input from the user blocks. That's the word. It blocks. And when you're combining a bunch of scripts together, install scripts, things like that, or password would be another time. When you're making scripts that are designed to be called by other scripts, you can cause inadvertent blocking that stops a system from working because it's sitting around waiting for somebody to type something in. All right. And we talked about the other ways to pass data into a script. And just as a general rule, so put a thumbtack into this, as a general rule, reading interactively from a user is a bad design. Okay. So even though this was fun for these interactive story games and everything, it is generally a bad idea, and I would be remiss to not tell you that. If you're gonna, I don't want you to go off coding enterprise stuff with a bunch of interactive prompts and then say, Mr. Rob told me to do that. As a general rule, thou shalt not block, which means if you need data, you provide default values, and if they're going to override those default values, you have them set environment variables, which we already did, or you have them set arguments, which is usually going to run out of space. There's a limit to how many arguments can be passed. Okay, or you feed one of the arguments is the location of a file, and you load up that file and you parse that file, and that is how Kubernetes works. That's what JSON's all about. That's what web APIs all do. Okay, they have structured data, and we're going to have an entire day dedicated to structured data. We're not doing it right now. Where you write a file that's got very organized structured data, and it contains all of your different configuration stuff in there, and then you point through an argument or environment variable or a default location, you point your program to that and you load that up. Sometimes you can load it off the web even, right? And that is, by the way, that's the basis of the Common Gateway Interface. Is the definition of these things through the environment variables that are set by the web server, which is answering a request from a user on the other side. And then those things come in as environment variables. Containers do the same thing. They'll set environments. The user has no way to interact with a container. They launch a container and they get one shot at giving it arguments at that time, but then from then on, they want to do anything to change anything, they got to change environment variables. And even then, some of those things can't be changed after the thing is run the first time. So the takeaway is don't block, and that kind of follows don't prompt. Okay, don't prompt. Or if you're going to prompt, have it be something that they add on. So, for example, SSH actually has an interactive mode. Keygen, SSH Keygen, and the other ones. There's several programs that have an interactive mode, but you have to ask for it. Okay, it's not the default. The default requires arguments or environment variables, and it just fails if they're not set. But if you want it to be interactive, you go through. One of those applications, by the way, is apt-get, and I'll give you a free sidebar here, a free tip. You should never use apt in a script. It even says, I'm going to read it right here. Always use apt-get. Here it is right here. Apt is intended for end-user interface, enable some options better suited for interactive usage by default compared to more specialized APIs like apt-get. If you're writing a script, apt-get is what a lot of people think apt is the simplified new version of apt-get, and apt-get is deprecated. Wrong. Apt-get is meant for use in scripts. Apt is meant to be convenient for the command line for interactive use, and that's what triggered this rabbit hole. Okay? So that's a bonus. Whoopsie. All right, so here we wait, did I do that right? All right, here we go. So let's open up Bridgekeeper again. Hey, hi. And what do we got here? So we have Bridgekeeper, and we're going to go down here. So what is your favorite color? As a king, do you have to know this? Okay, so here's our interactions, right? And we are now prompting for the username. Now, there's one other thing about read. Read has got an entire series of things you can read about it, okay? And we're going to be coming back to it more and more and more. Remember, it reads in standard input one line at a time by default. We're going to revise that later. There is something else, however, that you can add, and I'm not suggesting you add this. A lot of people do if they're just doing a one little thing. I tend to not do this, actually. And what they do is they can put this line here and they can combine it over here. Now, one of the reasons not to use this is because you can't use escapes with it. And so I'm not suggesting you use it. But if you do -p, when you do your Bridgekeeper program, it will actually, oopsie, did it do it? Did I do it in the wrong order? I did. Help read. I don't ever do it, so that's what prompt. There we go. Output the string prompt without a trailing. Oh, without a trailing new line. Did I? Oh, I forgot the name of the script. I forgot the name. Oh my god, I'm so dumb. All right, so you do -p, and then name has to be on the end. There we go. Is that gonna not do it? Oh, wait, I forgot. That's right. We're using POSIX shell. Yay, I'm glad we hit this bug. This is a good bug to hit for educational purposes. So shell check is saying, no, there's no dash P in POSIX shell. Let this be a reminder to me and everybody else. When you're coding POSIX shell, it is not compatible with bash necessarily. Bash or K shell or Z shell or whatever. Okay, sometimes they're not. Another popular one is Make-P, also not supported. There's several versions of SED, several switches on SWED that said that are not supported in POSIX. So yet another reason not to do it. And as I said, I don't do them. All right. So let's go back to our echo. All right. Let's go back to our echo. I just do -R. It's better. It's better. It really is. I mean, just do the plain, read whatever. Here's another reason it's better, because you can do here. All right, so it read it, yeah? Now watch. So wouldn't it be cool if I actually typed on the same line, right? How could I do that? Echo puts a line return after, so the answer is printf. I could put printf. What was printf going to do? I could put an extra space after here. And now when I run it, what's going to happen? What is your name? Oh, look at that. I put it on the same line. That's cool, huh? Yeah. One other cool little thing. What is the time? How much time we got? We got 20 minutes. Okay, so every time I get to this point, I always struggle because we're going to spend an entire day, at least an hour, on color. So you can understand this. And we have to really unpack color. But for right now, I'm going to just tell you how to add color. Okay. And we're just going to, it'll be kind of a sort of a, an enticement for the next time when we actually learn true color. So I'm going to do color. I have a color strip. Yeah, there's a color strip. And then we have term colors. There they are. So these terminal colors are all special escapes. -E stands for escape sequence, right? So that's as if it literally is if you hit the escape key, and then you type a left bracket, and then any number of these numbers, and we'll get into what the numbers mean. But what this does is it prints a non-printing. In other words, it's just an instruction to your terminal to tell it to change the mode or change that the setting for color, right? Particularly foreground color in this case. And so we're going to copy this out. Let's see. Let's make, how about we have magenta for our prompting? How about that? Actually, no. Let's just copy and paste all this in. Yeah. I'm being very lazy. Because you can put, for now, you don't understand what they mean. We will talk about them, I promise. All right. So those are all defined in variables. So now it's like, you didn't use it. You didn't use it. You didn't use it. You know what? Screw you. I mean, we have to decide what color we're going to use first. We're going to let it complain for now. It's fine. So ask me these questions. Okay. Let's make this yellow because we want it to be yellow. So let's put a yellow. All right. Now, then we have to put the bracket there so it'll do it. Also, echo doesn't do, watch what happens when I run it. Echo does gold. Yeah, it looks like it did it. That's interesting. Okay, but did you see how it bled? You see how it bled into everything else? Everything's all the color, right? In fact, it would still be doing it if it weren't for my prompt having color in it. So what do? We need to have a reset, right? So we're going to, at the end of it, we're going to put reset. And these are codes that are getting printed. Now, this is kind of a prefix to, we need to learn these color things because you want to make a fancy code prompt. You don't want to have to use oh my Z show or some stupid thing like that. So yeah. Yeah, I could have done that too. That would have been a great, yeah. Let me show you that. Watch. Bang, bang, term colors, done. Okay. Did you see what I just did? If you don't, here. This is a good opportunity to have you to learn the VI filter command. Okay. If you have the term colors command on your program, on your machine, which I do, bang, bang, it replaces the current line with the output of the program, term colors, boom. Right, and I can get rid of POSIX, and I can delete this one, and now I got my colors. You can use a filter there. So that's one of the things you can do. So printf is the same as echo. It looks like echo is doing the escape sequences, which it normally doesn't. Sometimes you usually have to do a -e or something, but it's doing it for some reason. I thought that was not going to work, but it is. What is your name? Let's make these magenta. Now, what happens if I do this? Obviously, it's not going to work. Why? Because it thinks it's one big variable, so you have to use the brackets. Okay. What is your name? This is a cool little trick. Right before we type in the name, we can make it a different color. Yeah. So we could actually make all of the things people type in white. Okay. And then after it reads it, we need to do a reset. Otherwise, it's going to be. We can either do a reset. It's probably a good idea to do a reset, just because it might be out of whack. You could also have just done it here, right? And you said you entered. So let's make this black because it's just like debugging information. Debugging information is black. Yeah, and what is this going to be? We'll make this red. How about that? Red. Yeah. You entered space. And also a reset. You probably don't need all the resets. It's a good idea. It's gonna ruin your day if you don't. What is your quest? So this is yellow, and you can probably see an opportunity for a function here, which if we don't get to it right now, we will. And stuff. Okay, so do we want to go back to using the case statement? Okay, so the last thing about the case statement that we did not learn is how to do else like this, right? So let's actually uncomment this. Going to the top of it, I'm selecting exclamation point, and then the entire section, which is right angle bracket. This is my method. You can do it differently if you want. And then I'm going to uncomment that. So I'm doing it the hard way on purpose, okay? So I'm replacing a hashtag at the beginning of the line and one space with nothing. And that uncomments it. Okay, there are a dozen ways to do that. People will usually tell you to use visual mode. I am deliberately doing it in a way that is compatible with VI, which does not have visual mode. I mean, it doesn't have it the same way as Vim. So that's why I did it that way. It also, that stuff I just did, that works with Ed as well. So I thought I didn't see color. I see color. Lol. Anyway, so now we have the two things. We don't need this one, right? So how do we add this one, though? And this gets back to CodePill's earlier recommendation before, star. So the glob star actually says all of the other things that it could possibly be, okay? Down here, we can delete all that. Let me show you how I deleted all this. So because all this stuff is all one simultaneous section and there's no white space in it, anywhere inside of here, I can dap. And I learned that from the Prime Agent, and I gotta give him credit every time. I mean, we've been at odds many times about different things, but that particular thing, for every single time I say I use it, I'm going to give him credit. He showed me how to use dap. I was just watching one day, and I've never seen it before. And that is a Vim-ism, okay? That is a definite Vim-ism. So, but I want credit to be where it's due, and I'm grateful I saw that. So, let's keep going to the next thing. Yeah, and I mean, you can disagree with people on many, many things, including like life, policies and missions. But when it comes to the terminal, we're all equal. We can all learn from each other. So, yeah, that'll also work. Yeah, that only works up here at the beginning, unfortunately. That's why I like DAP so much, because I'm never at the beginning. You know what else works? DAF with an F. Yeah, if you put an F in there, if you're anywhere inside of a function in Go, or whatever language has a function identifiers, it'll delete the entire function. It's super cool. Oh my God, it's like, or it'll yank it or whatever. Super cool stuff. DAF works in Vim. It does not work in VI, no. It does not work in VI, and that's why I didn't know about it, because I tend to be a VI only kind of guy. And I allow myself to use DAP and DAV all the time. In fact, the filter, strictly speaking, the inline filter is a Vim only thing. you can do it. It's just a lot more steps if you're doing VI. So, so there are a number of Vim isms that have snuck their way into my muscle memory. And I know how to do it if it's not there. So it's not like it's going to stop me from being efficient. And I think that's generally the argument people use about NeoVim or anything, is that I know how to do it the other way if I don't have it, and that is totally fine. And people tell me that about Emacs all the time. They're like, if I don't have Emacs, I know how to edit files and BIs. I'm good. If you're an Emacs user, great. And a lot of Emacs users are really amazing, and I don't have anything bad about them to say. Especially if they already know BI, so they're not going to be useless on a machine that doesn't have Emacs. So progressive learning is my main point. Make sure you learn the simplified way so that you can fall back to it, and use that if you don't have the other, right? And you may not know all the time what those things are. Occasionally it's kind of embarrassing to go back to VI and have me realize how much of them is still locked into my fingers. But if you remap escape to JK, shame on you. Or use Control C instead of escape, shame on you. That's you, Premagian. Seriously, if you want to do it, that's fine. I just think it's dumb. Anyway, he uses Control C instead of escape. I do not understand that at all. That sends an interrupt. It's like, why would you burn that into your brain? You're complete. I mean, escape is like the most common thing you're going to do in VI. Why would you burn that into your brain? You're completely useless on VI because your pinkies don't do the right thing. No, they don't control this. If you're using Control left bracket, good for you. If you're using, because that works everywhere. Unfortunately, I learned through Twitch actually that there are internationals who deliberately use Americanized keyboards because they can use Control left bracket on those keyboards, but international keyboards, some of them do not support Control left bracket as a hardware replacement for the escape key. And those people are actually one of my best, most productive peers on my team. He uses his ring finger. I'm not flipping you off, I promise. He uses his ring finger to hit the escape key, and he does escape. He uses the actual escape key every time. And I'm like, dude, you must be really, adroit with at moving your fingers around. C left bracket was a terminal thing, not a hardware thing. No, it's a hardware thing. Well, it's a terminal thing, but it's a low-level TTY terminal thing. Does that make sense? As I understand it, Control left bracket sends exactly the same hardware thing to the terminal, and it gets interpreted the same way. Escape generates, whatever. Yeah, that's actually because that's how it gets demonstrated. When you see control sequence, let me show you. When you see control sequences in a file, they are caret left bracket. So, there's that. All that stuff that we just did with the color. If you like, let me show you. So if we run bridge, I'm going to do this. This is kind of fun. Bridgekeeper. Okay, what is your name, Rob? You entered Rob. What is your quest? What is your favorite quest? We got to do color still, but watch what happens if I try to redirect that. First of all, it's going to croak, right? Actually, let's do this. Let's give it some input so it doesn't croak, and then let's redirect the output to a file, temp foo. All right, now let's look at the file in VI. If I could spell. Okay, there you go. All right. Keyboard that, but there's also no. Yeah, it's up to you. You make your own decision on that. I mean, obviously when I started SKILSTAK, I was in America, so I was recommending Control left bracket to everybody instead of escape. I do not think you should remap other things because those are not going to be available on VI anywhere. And Control C is objectively wrong. It sends an interrupt, and if you do that on Alpine, it'll kill your VI session. Instead of just escaping you. So there are certain things you just don't want to replace, and that's my biggest gripe with what Premagian teaches everybody. But it's a small thing. I mean, it's a major thing, but it's a small thing. So here you go. See these, like this right here? Remember \E? Guess what that is? \E is the escape sequence, right? And that is what is written. So an escape sequence followed by a left bracket, followed by the number 33 and an M, tells the terminal that combination of things ending with M, that tells the terminal change the color to whatever, right? And there's a whole bunch of these, and we're going to break them all down. This dates back to the stuff we talked about extensively about how the terminal is an evolution of the teletype text printer machine with the line returns and case returns and all that stuff and color changes and everything. And at one point, I think color was actually changed. It was actually supported on the actual printer. So that's what's happening. So when the printer sees that escape sequence, it knows to start changing the color of the ink or whatever. Okay. But you can still see these things in the stream of data if you redirect them. If you see now set no list, you can even see these without a list, but see that you can never actually type that into the program, as far as I know, right? So generally speaking, that's why we'll put that. But sometimes when you redirect them, if you can get one and then put it in there, it's actually really cool because that character is already it's already escaped. It's already in the content. So you wouldn't have to do anything special to the content. I've done that occasionally, like when we do like the lights, is it highlights? Yeah. So they had the highlights. So like this right here, right? So this is a highlight. So we'll maybe write this a bit later sometime. We're gonna come back to the sequences things and the colors and stuff. So I don't want to drown you right now with all of that stuff. Plus, we only have 5 minutes. So that is fun, and we might start with that next week because colors is something I've found along with silly Python, Monty Python memes, make it fun. And I've noticed that adding color pretty early makes these projects a little bit more fun. And now you know how to do it. You know the basics of it. So, yeah. So yeah, people have got different themes. Yeah. Non-standard answer sequences you can do. Oh, there's amazing things you can do. Yeah, you can like I don't want to crack that egg yet. I know everybody's really anxious. There are so many things you can do, including rewriting to the screen. That animation I just did, we're going to get into that. I promise you, we're going to rewrite all of that. Right now we're learning conditionals though. So we have our condition, right? Let's actually go through, let's finish our colors on this. We only have a few minutes left. And let's just get it to where it needs to be. What is the capital of Syria? And we still need some if conditions here. We've done the basic if conditions. If you want to this week, if you want to go in here and have it actually be more interactive, you can do that, right? But you know the basics of these conditions, and you know how to. That's the goal for this week. The goal is to do the interactions, to be able to conditionally do different things, and to do the prompting, and to introduce you to color without overwhelming you with color. Okay, that's really it, and that's it. We were going to do repetition, but I think we'll save that for another day. Normally, there's another project for that anyway. Do you like waffles? Yes, we like waffles. We're going to do that one. And badgers. We're going to do the badgers program. I'm going to keep my ancient meme thing. We're going to do badgers. These are ancient memes. People probably remember. We'll do the badgers one for repetition. So here we are. We got this thing. Now, we're going to come back to this, though. If you want to take a stab at doing something this week, too, see if you can make this easy. There obviously is an opportunity here, isn't there? Do you see an opportunity for refactoring here? So what is the capital of Assyria, right? So I'm going to make this gold again. Yellow, sorry. All right. So do you see an opportunity? Let's make it a printf. All right. So what do you see? Throw it out in the chat. Do you see something already? Go ahead and spit it out. All right. Do you see an opportunity for a refactor here? Do you see an opportunity for a refactor? We will do the refactor, but I want to see if you want to take your hand in it this week. All this repetition I'm doing is making me think I could have done it an easier way. Yeah. What could I do here? What can I do here instead? Instead of making it white. What if I want to change the color that's prompted? Right now, what do I have to do? I have to change it every single time. Oh my God, Rob. Oh my gosh, Rob. What a bad programmer. No. Okay, so yellow. Can you see what I'm saying here? Use a procedure. Yes, yes. This is a perfect time to use a procedure / function. And you know what? This week, go try it. Try it. If you want, we already did them. You know how to do them. Give it a shot. See if you can make that happen. Right? Oops, I got a problem here. Thank God for. Why is it yelling at me? Don't use variables. You know what? I want to tell it to shut up about that. Yeah. It's trying to, you know what it's trying to tell me to do? I don't want to. How about echo then? Can I go back to using echo? I know what it wants me to do, but I don't want to do that. I know why it's doing it. I just don't like it. I don't want it. I know it's not, watch. It's gonna tell me I have to escape it. It's gonna have to. I'm just gonna say you have to quote it now. This is one of those times when I would just tell it to shut up, or I'd use echo dash n. There is no echo dash n in shell. I don't think. Yeah, let me try that actually. We're gonna try it with echo. Echo dash n. There is no echo dash n in shell. Oh, okay. Well, now you know why I don't do that. Printf is totally fine. It's totally fine. Shut up. I'm gonna tell it to shut up. Yeah. There's how do you tell shut up to shell check? Shell check. Ignore. There's a way to tell shell check that I got this. Leave me alone. There it is. Shell check disable. All right. So there. This is probably a good time to do this. A shell check disable equals what's this one down here? SC2059. SC0259. Oh, it's not working. I think it has to be the first line. I don't know that. Don't use variables. It's not working. I know it runs fine that way. Disable SC2059. Oh, it has to be on the same line. Huh. I wanted to do it for the whole file. I think it's a comment. Yes, it's a comment. I'm sorry, I didn't remember that. It's a comment. Of course it is. Yep. It's still not working. God darn it. God darn it. How come I can't get it to work? Does it have to be in a wait. Does it have to be every single line? Or does it have to not have a space here? Yeah. Does it have to be like on the line above it? I don't do this very much, obviously. Huh. You know what? It's ready to the start of the script. You know what it is? I don't think Gale is seeing it. Yeah, this is something new. This is a Gale problem. I don't think Gale is seeing it. Did I spell it wrong? SC2059. Oh my God. Is that really all it was? Oh, I feel so stupid. Stupid. Okay, I'm not using green, so common in green and blue out cyan. Actually, we can take those completely out. I am so sorry. I didn't use that before. I am so sorry. Yeah. Yellow. Deal with it, shell check. All right. So that was a good lesson in how not to be an idiot and type numbers wrong. Also, how to disable shell check. I mean, when you don't want to. Okay. We need to get going with Go. We're already into the Go time. If you are here for Go programming, we are going to start momentarily. But we're just wrapping up this other one. and then we're going to take about a 3-minute break, and we'll get right into the Go programming. So Go will be. I should probably put a break in here in between, like hard code the break. Let's start at 210-ish. Okay. Yeah. So that's cool. So you can go ahead and do disable. For the more annoying ones, you can put those in there. And I mean, it's actually kind of an indicator that somebody knows what they're doing is when they have shell check disables in their shell scripts. That means they're using shell check. And it's a good sign, right? In my opinion. You already know the opportunity here. In fact, I'm kind of tired of fixing this up. So next week we will do that. So for homework, make something that makes it so I don't have to type yellow, white, and I can actually just change it, whatever I want to change the color. Okay. Let me actually add a thing here. Repeat something more times. We didn't get to that. Read entire file, didn't get to it. Actually, status basis show. We got to that just up here. We got to that. Do I need an entire file? No. Regular expressions didn't get to it. How do I get something in every file? We haven't done that yet. What is the primary expansion I can use? We haven't done those. Well, those will be next week. We did do this. How can I change the colors of text and user input? Okay, we did that. We talked about that. And that is good. This guy will go into week 20. Copy week 19 to 20. This stuff will all be up. So we'll be publishing this right away. I do need to add. Sometimes I'm a little late on the video, getting it into the right place. I apologize for that, but I have to get it on the right playlist and everything. So that's pretty much it for today. Hopefully you had a good time. I did, and we will be just plugging away as we go. Pandoc and shell check. Those are the ones I use all the time. Oh, I know. Pandoc and shell check are both Haskell. I love Haskell. I love me some Haskell. Yeah, I'm not very good at Haskell, but I do love it. It's a great language. For this particular kind of thing, it's perfect. For tokenizing something and doing that, it's literally hand built for that. We will be biking today, yes. So just to recap on the calendar during our break here, and then I'm gonna actually stop the stream and restart it so we have a fresh go thing. So here's the calendar again. So calendar today, we're supposed to be doing Go right now. I'm going to push it back to 1:15. I'm going to actually push all of them back because I want a little break in between. And then we're going to be biking today. And we're going to be using the rig and trying our f-stops and be doing that today later at 3:45. So in general, the outdoor stuff happens at sunset, a little bit earlier before sunset time. That is when, if you're here for outdoor content, that's what it's going to be. I'm just decided to stream them all to the same place. If you're here for tech content, Sundays or during the day, right? If you're just here to co-work and listen to music, almost always during the middle of the day on the weekdays. Okay? So I'm going to go ahead and drop the stream. We will talk to you in a bit. If you're here for Go, please stay tuned. Bye.